Hello and welcome all my grade 11 elite students to today's session. Today we are covering end of term questions exam coverage, and it's a must watch and a much requested video from all the grade 11 elite students. So today's video is part 1. We are covering module 2 polar coordinates, and this video has selected solutions to the exam coverage important questions. So must watch video, watch it till the end and take maximum benefit from the questions that we are discussing here. So let's get started, and before we do that, a humble reminder, a kind request to like, share and subscribe to the channel, and to share this video with most of your friends so that everyone can benefit from the session today. So in this video we are covering module 2 polar coordinates, and let's get started with the important questions. Okay, so here you need to find three different pairs of polar coordinates that name the given point between the range theta lying between minus 360 to plus 360, or theta lying between in radians in minus 2 pi to 2 pi radians. Okay, now what is the concept that we'll be using? If we are having the angle in degrees, then the points will be r comma theta plus minus 360 degree. This will be the three different pairs of polar coordinates, or it will be minus r theta plus minus 180 degrees. Okay, this is when the angle is given to you in degrees. So these are the points that will be giving you the three different pairs. I will just show you for question 14 how we apply this concept. Or if you are taking the angles in the measure of radians, then the point would be same point, just you replace 360 with 2 pi radian. So plus 2 pi, this is the radian point, and minus r with theta plus minus 2 pi. So these are the points that are going to give you the answer. So let's apply for 14th question the same concept. So the first pair of points we will take as r comma theta minus 360 degree. I'm choosing it from here because the angle is given in degrees. The second pair would be minus r theta plus 180. I'm choosing it from here, and the next one would be minus r theta minus 180 degrees. So let's plug in the values. What is the value of r? It is 1. So r is equal to 1, theta is equal to 150 degrees. This is for question 14. So the point would be 1 comma theta is 150 minus 360. This one is minus 1, this one is also minus 1. Theta means 150 plus 180, and 150 minus 180. So what is the answer? Let's see. For the first one, the point would come out to be minus 1 comma 210. For the next one, it will be minus 1 comma 330, and for the last one it will be minus 1 comma minus 30. So let's write the answers. So the answer is 1 comma minus 210. That's one pair of points. The next pair is minus 1 comma 330, and the next is minus 1 comma minus 30. So this is how you get the answer. Same concept you can apply for questions on radian. So let me do one question on radian also for you. Let's do this one. So I'm going to use this formula. Okay, so r is, that's right, r is 4 and theta is minus 7 pi by 6. So I'm going to use 2 pi here. So this will give you 4 comma minus 7 pi by 6 minus 2 pi. That's 1 point. Next is minus 4 comma minus 7 pi by 6. Oh, there's a mistake here. It has to be pi. So this one is, one will be with plus pi, one will be with minus pi. So when you solve it, the final answer would come out to be, just simplify the angles. So it is 4 comma 5 pi by 6 minus 4 comma 11 pi by 6, and last one minus 4 comma minus pi by 6. Now here you must be wondering why I'm taking only negatives. You may take positive also. So there are actually 4 pairs here, 4 pair here. So any 3 pairs you can select for your answer. Okay, so if you solve in a similar way, the final solutions for all these problems would come out to be this. Remember, this is not the final answer. There can be one more point. So if you're getting the 4th point, that's also correct. So these are any 3 points or any 3 pairs of polar coordinates that are lying in between. So just remember the formula that we've used in the last slide, and that will help you for getting to the correct answer. Next, let's move to the graphs. So this one is a pretty easy one if you see carefully, and you will be getting the correct answers. It looks tough, but it's quite easy. So let me give you some tricks that will help you. So first things first, this is on page 73, the concept that I'm going to be discussing. So you may use your math book to refresh the concept. And if you know about polar and rectangular coordinates, so your polar coordinates are r comma theta. This learning objective is to convert between polar and rectangular. Rectangular is x comma y. So the conversion factor that you use is x equal to r cos theta, y equal to r sine theta. These are the polar coordinate conversion. So for each question that you see, you are given here the rectangular equation. It is in terms of x, in terms of y, right? So very easy to identify in rectangular. So if you see, this will come out to be a line. This will come out to be a line. This is like a line passing through x equal to -2, so it will be in fact a vertical line. This one will be a horizontal line. This one will be a circle. So even before you draw the graph, looking at their equations, the rectangular equations, you could identify what conic section it is. So if you see, it is asking, write the equation in polar form, then support your answer by graphing the polar form of the equation. So you know that you have identified the graph is going to look like this. So this is again a circle, this is a hyperbola, this is going to be a circle again, circle, lots of circle, parabola, and a circle again. So from rectangular you have already used the knowledge, and you can see here the graph is going to be a line, circle, line, parabola in each of the parts. Now coming to the polar equation, converting from rectangular, which is given to you, to polar equation, how we do it. So let me do one for you. So 26x is equal to -2. So I told you the conversion is x equal to r cos theta, y equal to r sin theta. We don't have y here, so just let's plug in for x. So r cos theta is equal to -2. So I have to write it in terms of r. I take cos theta on the other side. So it divides, and the reciprocal of cos is secant, so -2 secant theta. So what is the polar equation? R equal to -2 secant theta. So that's what you get here for the line, and you know it is going to be a vertical line passing through the point -2 here. Similarly, for the circle, parabola, you can also do the same. So let's do it on the next slide. So I'll be solving question 27 here now. Pay attention. So x equal to r cos theta, y equal to r sine theta. This is the conversion I'm going to be using for the circle. So r cos theta plus 5 whole square plus r sine theta whole square is 25. What I have done in this first equation, I have just substituted these values. In place of x, I have put r cos theta. In place of y, I have put r sine theta. So let's just open up. This is a plus b whole square. So r cos theta whole square plus 5 square plus 2 times 5 times r cos theta. This is r sine theta whole square. So r square sine square theta is 25. Now r square cos square theta and let me change color, this one and this one can be combined together. Yeah, because we are going to use our knowledge of trigonometry. So 5 square is 25, 2 with 5 is 10 r cos theta equal to 25. Now we'll do some simplification. First of all, 25 and 25 will cancel. Now r square will become common here. So sine square theta plus cos square theta, you know, is 1. So we are going to simplify this a little bit more. So r square plus 10r cos theta equal to 0. Now I can take one r common here. So this is r plus 10 cos theta equal to 0. So either r is 0 or r plus 10 cos theta is 0. So I have used here 0 product property. So if r is 0, the equation is 0. It's a point, so it's neglected. So the correct equation is this one. So now I write r equal to, I take this on the other side, minus 10 cos theta. So this is going to be the correct answer. And as you know, this equation, now if you have forgotten rectangular coordinates, let me quickly revise. This is the equation of a circle. How do I know that? Because x minus h whole square plus y minus k whole square equal to r square is the standard form of equation of a circle. So here the center is h comma k. So how much is h? Minus 5. How much is k? It's not there, so 0. And what is the radius of this circle? It is 5 square. So radius is 5 because 5 square is 25, right? This is given to you. So therefore you know that when you are drawing the graph of this circle, you have to start from the center minus 5 comma 0 and draw the radius as 5. So that's why you saw in the last question the circle was starting from the point minus 5 comma 0 with the center and a radius of 5. That's how you do the graph. Similarly, you may do the conversion of this parabola, you can do the conversion of the hyperbola, and accordingly you will be getting the following graphs. So these are the graphs for question 30 to question 35. So here you can see the circle is there, here the hyperbola is there, here the circle is there, here the line is there, here the circle is again there, and here also it is a circle. So you have learned in this question how to convert between polar and rectangular equations, and the main thing you need to remember is the formula x equal to r cos theta, y equal to r sine theta used for the conversion, and your knowledge of rectangular coordinates. For this question, write and graph the polar equation of a conic given its eccentricity and equation of the directrix. This question is by the use of graphing calculator, so it's very easy. You have to just punch in these instructions on your calculator and you will directly get your answer. But I'm going to show you a different method here so that without the calculator, how you can know what kind of a graph it will be. So let me just do one of these questions for you, like question 26, and the concept that I'm using is given in lesson 2.4 on your book on page 83 to 84, so you can refer to that. And the formula that we are going to be using is R equal to ED over 1 plus minus E cos theta, or R equal to ED over 1 plus minus E sine theta. So these are the polar equations of the conic given to you. Now, which conic it is, you have to determine which type of conic it is. So you have to see whether it is an ellipse, or it's a parabola, or it's a hyperbola. It depends completely on the value of E. So if it is E equal to 1, it's a parabola. If it is E more than 1, eccentricity is more than 1, it becomes an hyperbola. And if eccentricity is less than 1, it becomes an ellipse. So this is what you have to remember. So it's an ellipse if eccentricity is less than 1. It's a parabola if eccentricity is equal to 1. And it is an hyperbola if eccentricity is more than 1. So this E is very important. And we are going to solve the question using the concept of eccentricity only. We will use that for identification. So let's see how we do that. So I'm going to do, as I told you, question 26 for you. So for question 26, let's see what is to be done. So in question 26, R is given to be equal to 2 divided by 2 plus sine theta plus pi by 2. So here, how we are going to do it? Let's see. So I'm going to first write the equation 2 over 2 plus sine theta plus pi by 3. Now if you compare this equation with this one, so let me just change color to make things more easy for you. So compare this equation with this one. Why I'm comparing these two equations? Because sine theta is here, cos theta is here, and in this question sine theta is given. So I'm going to compare sine with sine. So you compare sine with sine, you see that you need a 1 here. So and here there is a 2. So what do? I have to remove this 2 and make it 1. So that means I have to divide the equation by 2 on both sides. So I divide the numerator by 2 and I divide the denominator also by 2. So what do I get? 2 divided by 2 is 1 over 1 plus 1 by 2 sine theta plus pi by 3. And now, is it in this form? Can we compare? Yes, because this has now become 1 and this is also 1. So now you can compare and you can get your eccentricity as 1 by 2. So if your E is 1 by 2, means it is less than 1. So which is this conic section? It is an ellipse, right? So easy one. And one more let's do from this one. So compare this with this one because it is cos. So cos is there, so 1 is already there. I need not divide by anything. So what is the value of E? E is minus, E is plus 1. So if E is equal to 1, what kind of a conic it is? Parabola. So when you see the graph for 28, it is parabola. For 26, it is ellipse. Similarly, here also the value of the value of E is 1. So it's an parabola. And for the last one, the value of E is more than 1, so it's going to be a hyperbola. Let me do a little bit for this also, just to help you out. So R is equal to, now there is a 2 here, there is a 1 here, so very easy to identify that 4 over 1 plus 2 sine theta plus 3 pi by 4. You are comparing with sine value. So what is the value of E? E is this number multiplied to sine. So E is 2, which is more than 1. So it's a hyperbola. So it will be this graph. So with calculator, without calculator, both methods have been explained here. So all the very best. On the same learning objective, it is this question. So we are going to use the same formula. Let me write it here once again for you. The polar equation of the conic R equal to ED over 1 plus minus E cos theta, or R equal to ED over 1 plus minus E sine theta. So here you have to do match the following. If you see the 4 graphs are given to you, the 4 equations are given to you. You just need to match them with the correct equation. So it's a easy question. Just compare the value of eccentricity and you will get your answer, just like the last question that we did. So here this graph is, you can see very clearly, a parabola. So what should be its eccentricity? 1. Here it is a ellipse. So what should be its eccentricity? Less than 1. Here it is a hyperbola, so its eccentricity would be greater than 1. And finally here also it is a parabola, so its eccentricity is equal to 1. Now let's compare the equations. So if you see this one, it is cos theta, eccentricity is 1. So therefore, definitely it is going to be a parabola. So therefore, you match this with this equation. Okay, next is question 31. This also has eccentricity. If you compare with this equation, the value of eccentricity is 1. So you're going to match it with this one. Then here the eccentricity can be calculated. See, now here if you just see, you will say it is 1 and you will do the wrong answer. But you have to look at this number. It is 2. So you have to convert. So r is equal to 5 over 2 minus cos theta. That means you divide by 2 on both sides. Why you divide by 2? So that you make this 1. So it is 5 by 2 divided by 1 minus 1 by 2 cos theta. So now it's good to compare. So the eccentricity is 1 by 2, which is less than 1, and that makes it an ellipse. So therefore, this one will be matched with B, the ellipse. Here the eccentricity, very clearly you can see eccentricity is 3 more than 1, so it is the only option for hyperbola. So this is how the matching has to be done using your knowledge of polar equation of conic and eccentricity. Okay, let's now solve the last question of polar coordinates. Here you have to convert between, you have to express each complex number in polar form. So now let me give you the concept. So first of all, if the complex number is z equal to a plus ib, so a is the real part, b is the imaginary part, okay? Then the magnitude or the modulus of this is given by absolute value of a plus ib, which is equal to the square root of a square plus b square. So this formula will help you to get the magnitude of the complex number. Now the angle of the complex number. The angle is given by tan inverse the imaginary part divided by the real part. So these are two important informations. I'm just highlighting them here. So this is the magnitude formula, this is the angle formula. Now once you have got your magnitude is also denoted by r. Okay, so once you have got your value of r and once you have got your value of angle, you can write the polar form of a complex number. So the polar form of the complex number z is equal to r times cos theta plus I sin theta. So this is the main formula that will be used in this question for solving the questions. So let's do one of them. Answer 10. So if you see, if you compare z equal to 4 plus 4i with a plus ib, then how much is your a? 4. How much is your b? 4. So let's calculate value of r, which is equal to square root of a square plus b square. So this is 4 square plus 4 square. So this is 16 plus 16, which is 32 square root, which is equal to 4 square root of 2. So I have got my r as 4 of square root 2. Now I need the angle theta. So theta is tan inverse b by a, which is equal to tan inverse 4 over 4. Both are equal. So what is tan inverse 1? It is in radians pi by 4. So we have to take the angle in radians. So when you take that, this comes out to be the value of the angle. So we have r, we have theta. So what will be the polar form of this question? It will be r equal to 4 square root of 2 cos pi by 4 plus I sin pi by 4. So this is how you get your answer. So in a similar way, you can see the answers of the remaining questions which are given here. So please solve them well and you will get your correct answer. Inshallah, from my side, best wishes to all of you. I hope this video was useful, and if it was, give it a big thumbs up, like, share and subscribe to my channel. Share with your friends who are in grade 11 and who may benefit from this video. I know it was a much awaited video, but have patience, more parts of the video are going to come up for you. It is taking a lot of time and I'm spending my National Day break for making videos for you, so just be patient and make the best of it. Like, share and subscribe to the channel. Until then, this is Ms. Ruchika signing off from my session today. See you in my next video. Bye students.